Hello, welcome to another episode of Fix It Tony. Today I'm in my kitchen and it's in my sort of eating area. So it's a place where we have a counter with some stools and we have an outlet here. And oftentimes, people sitting at the table, they want to charge their device, right? So they want to plug in. And they've always had to use a charging block along with their USB cable. And nowadays you can buy electrical receptacles with USB ports already in them. And I've installed this in one of my son's bedrooms, and it's definitely gotten good use. The benefit is all you need is the cable. So you don't need to have the charging block. Plus it looks neater if you have a cable plugged in, I think, than having a charging block sticking out. The other benefit is that you still maintain access to the two regular 120 volt outlets, even when you're plugging something in. So instead of using a charging block and consuming one outlet, you actually keep it free. So today's project is going to be this. So I'm going to take it on a little bit on the slow side so I can talk through some basic electrical concepts and things to consider when working around electricity, and also with the receptacle and some basic tech. A few comments about the receptacle in general. So electrical codes will vary state to state, but there's a national electric code. What is common in a lot of receptacles these days is tamper evident, or tamper resistant. And what that means is if you look inside the receptacles, you're going to see sort of like a thin plastic cover. Really can't see it on the camera. But what that is supposed to intend to prevent is a child, for example, wanting to stick a paper clip or something. So here, let's just try and stick a paper clip. You can there's some resistance. So it's supposed to keep you from really getting shocked, but I think the safest thing to do is to put outlet cover protectors on if you have kids. So this unit is going to be sort of big and chunky. So one of the things we're going to have to make sure is we have room in that junction box, and depending on how many wires are in there, it could also run into issues. If there's too many wires in there, it could exceed the maximum volume capacity or number of wires per volume. So we won't know until we open that up. So the tools that I think I'm going to use today, you can complete this project using all hand tools. If you really have an electric screwdriver like I have here, you can speed up the process of a little bit by not having to use the hand tools. But I think if you're a novice, I would stay away from this because you may create more damage than time you save on speed of unscrewing and screwing the screws. Before you open up any receptacle or switch, you have to make sure that the power is turned off to the receptacle. So you have to go find your electrical panel box, and it'll either be breakers, so black switches, or fuses if your house is old enough with screw type fuses. But let's just assume everyone nowadays pretty much that'll be watching this video will have circuit breakers. So if you're lucky, the circuit breakers will be labeled neatly, and it'll give you a ballpark of what circuit the receptacle or switch of interest may be on. But keep in mind, this receptacle is straddling between my dining room and my kitchen, also my front foyer and staircase. So when the electricians were wiring this outlet, I really don't know which circuit they included this on. I'm going to first locate the kitchen outlet circuit breaker, and flip that one, and then come back upstairs and retest the circuit. Speaking of testing circuits, if you're ever going to have any, I think if you're a homeowner or even an apartment dweller, condominium, it's important to have some very basic circuit testers. This one here is, to me, has served me well over the years. I've had this one for 20 years by a good name brand, and this particular one offers you the opportunity to test for whether something has hot wire, open circuits, open ground, test for whether or not the circuit is correct. So I'm gonna, and it's easy, right? You just plug it in and then you'll get the outcome. So you see here, 2 lights turned on, these 2 orange lights, not the red one. So what that tells me is that it's this combination down here and that this receptacle is wired correctly. But it also tells me that it's actually hot. Another voltage detector or tester is one like this. It's sort of a pen device. It's a one-trick pony though. It only tests for live circuits. Battery powered. You flip the switch. Always test on a known circuit before you trust this thing actually works. It works the same way. You just kind of plug it into the outlet. And that noise and the blinking light means that there's electricity in the circuit. So I gotta go turn off power to this circuit. All right, I'm back, and I was lucky. I had 2 circuit breakers labeled kitchen outlets. I flipped the first one, came back upstairs, and as you can see, no lights are on. All right, so I know that there's no electricity going to this outlet. I'm going to begin taking it out. Now, what you want to be careful of whenever you're working around electricity, make sure you save all your screws. They do sell screwdrivers that don't, that the metal shaft isn't exposed, it's covered and protected. As long as you know the circuit's dead, you're gonna be okay. But you should probably get into the habit anyway, if you're working around electricity, not to touch the metal shaft. Keep your hand on the rubber handle, okay? But if you know it's off, then, you know, use your judgment, right? The cover's gonna be the safe, not gonna be charged with electricity. So now this is gonna be a Phillips screw or a slot head screw. So you could use my Phillips. It looks as though I have enough room. The other thing I noticed right away, and this is a real big no-no, is that whoever installed this outlet did not drive this screw all the way down. This screw should have been driven all the way down and not be left unscrewed like this. I'll take a look on the bottom side when I pull out the outlet. But that's just, keep in mind that this should not be that way. All right, so yeah. You're gonna unscrew these terminals. These terminal screws, another thing to point out, they don't come out all the way. They have, something has been altered to the screw ends, that they don't come out all the way. So as you're loosening them, when it starts to get tight, stop, okay? If you pull the screw all the way out, then it alters, it's hard to get it back in, first of all, but we want to make sure we want to maintain the integrity of this receptacle in all aspects. If you don't have strong fingers or you're worried about your fingers, you can get a pair of needle nose pliers. These I've had for years. They work well. Then you just sort of grab and then pop off. It can take some bending back and forth, but you gotta be very gingerly about it. It will snap if you go back and forth too much. So what I'm gonna do now is just flatten the wire. So what I'm doing is taking any bends, lining up my pliers and just squeezing, and I'm basically creating straightness again. And when you're bending a wire back, you can kind of go a little bit deeper with the needle nose and then open it up in one motion. You can see how most of it is. And then I'm going to flatten it out because I want to see how long this is. This black wire has been extra abused here. There we go. There. So now we're going to get ready for the new receptacle. So we can wrap it around the screw. The other option is to push it in, and then there's this clamp. Let me get a pointer. So this metal piece is connected to there's like a flat nut in behind here, so then as you screw the screw in, let's see if we could sort of see it. So you can see that bar right there. That has to be on the outside of the wire. So then I'll show you as I tighten the screw. You can see how that is coming in and pinching. So you can actually pinch, that'll actually tighten the wire. That's one option. That would work too. And I'm debating, which, and this too also, it will sort of stop. And when you do, you want to stop it because you don't want the nut to disengage. You can look at the instruction manual, but you can also look at the color of the screw. So sort of a shiny chrome color screw is going to be where the white wire goes, with a neutral. The brass colored, this instance is brass or copper. A darker screw, it could be black sometimes. This is where the black wire is going to go in the back. So the question is then how long should this wire be? So one way I can test is by actually sticking it in. So what you're going to do is turn it upside down for this screw to fall all the way down, and then push that in. And then you can see I got some copper showing. I don't want to have any copper showing, okay? I don't want to have any, so I'm going to trim this. Okay, so that's basically, I'm going to trim all these to the same length. Sometimes there's a strip gauge on the back, so here there's a small strip gauge, and you would line up the wire to that, and then it's essentially saying the same thing. A little tougher. I'm just going to trim a little bit. Now, my needle nose pliers has trimmers, but I like these flush cutting pliers a lot better. So I need to know how much I'm going to be stripping. So I'm going to, let's see. Then I'm going to measure the length. By lining this up. And then same length. The ground is really long. Now there is a general rule of thumb. There's an electric code requirement that beyond the surface of this box, the wires have to extend about 6 inches or so. I think, you know, that is the purpose, is to allow a person to kind of use and manipulate. If your box is really full, mine's empty, it's only got the one pair of wire. You can kind of keep these a little longer, and then you'll just sort of tuck them in. Tucking them in is also going to be tricky, as I will get to. So the approach that I take is I will always start with the ground wire and white wire, and then the black wire last. And I always do that in the same order in every connection I make. The thinking is that if I ever make a mistake, I'm always protected. If in fact, if I am working with live wire. So I need to rebend. Now to bend the wire, all right, next step is I need to make a bend. Usually, this comes with experience, but usually I don't pinch it right from the tip. I go a little bit in, and then I grab it a little bit farther down, and then in one motion I go 90 degrees, and then I adjust my grip, and then I pinch, and there. Then you kind of create your, let's see if you can see that loop. Okay, now that I did it, then you tighten the screw. You don't want to over torque this because you could strip the screw. So you go a little bit tight. You know, that's pretty tight. I don't know the exact torque setting, but that's that. So the next part is to get the neutral wire, this one connected. And as I said, we're going to use the back insert points. One of the other things I want to keep in mind is the orientation. So which way do I want my outlet to face? This way or the other way? Now, there's a natural tendency for the way the wires have already some built-in tension for it to naturally want to sit this way. So I'm not going to fight the natural tendency of the wire, of what it wants to do. So I'm going to just abide by its wishes, its inclinations. So I am going to flip this around so I can see here the screw is going to come out, and then I'm going to stick my wire in, and then I'm going to tighten. Let's see if I can get this in there. All right, so we have what you're listening to are our lovely family members. So I'm tightening it, and I'm going to inspect. See that? And pulling. So you gotta do the pull test, and then do another little turn. There's a feel, right? You know you're gonna go too tight. It's part of the torque is, you know, the size of the screwdriver, the length, and your, you know, the twisting and the bite of the tip. You know, you can definitely over tighten this and break it. So there's a certain feel to it, but you kind of know when you're reaching the limit and when you're overexerting. So, you know, just be mindful of that. And then we'll flip it over, twist it back. Drop that down. There we go. I'm sort of holding this up and stabilizing the receptacle as I'm tightening. As you see how it skips, it torques out. Then I do the pull test. I am pulling pretty hard. It's not budging. And then I do a little bit of a turn. Now it's time to insert the receptacle into the box. So one thing is you have to keep this ground wire from making contact with either the white common or the black power. If it does, it shorts out. It can cause a spark. It'll blow a breaker. Not a good thing. So what I'm going to be doing is sort of bending everything, sort of bending things, folding the wire. Let's see if I can get in close. I'm folding the wire. I'm going to keep it you want to keep the ground off to this side if you can. Okay, so the way I'm going to do that is bend it up, and then I'm going to bend it down, and then I'm going to bend it up. And then the bends just sort of continue, and I know that my ground is out of the way. So what a sign of a professional, or someone at least pretending to be one like me, when you're tightening your cover plate cover screws, most people just sort of leave them in a position where it's been tightened. What I like to do is tighten them all so that the slot is the same on both sides and lines up lengthwise of the box. Okay. That way there's balance. You see the slots to the receptacle, the USB, and the screw heads, they all line up. So a sign of someone who's taking their time, taking care, and provides good workmanship, I think, pays attention to that last screw on the outside. After all, this is what people will see.